Hello gentlemen, hope you are doing good. Today in this video, we are going to learn Galilean transformation equations. Also we will learn velocity and acceleration equations in this video. So gentlemen, in our last class we have already done frame of reference and inertial non-inertial frame of reference. So now we are going to do Galilean transformations as I already told you. So as soon as this topic comes in your exam, just a second, Galilean transformations. You have to make a diagram. This is y-axis, this is z-axis, and this is x-axis. This is y dash, this is z dash, and this is x and x dash. So as I already explained you this diagram yesterday, this is y, z and x coordinates of stationary frame of reference, and this is y dash, z dash and x dash coordinates of non-stationary frame of reference. This is a point P in non-stationary frame of reference, and the distance of this point from y-axis is x because it is in x coordinate, and distance of this point from x dash is x dash, and time taken or the distance from this point to this is vt because distance is speed into time. We are doing all these things because we have to find the coordinates of a point in some frame of reference with respect to other frame of reference. So first of all, we are going to find position equations. So let us consider that two frame of references S and S dash, where S is stationary and S dash is moving with velocity v along x direction. The coordinate in stationary frame of reference is x, y, z and t, and in non-stationary frame of reference is x dash, y dash, z dash and t dash. Therefore we obtain position coordinates in S to S dash as follows. So x dash is equal to x minus vt, as we can see from the diagram. So x dash equal to x minus vt, right? And our y dash equal to y, because we are only considering all this situation are happening and conditions in only x coordinate, and that's why y dash equal to y, and z dash equal to z, and t dash equal to t. And now this is a question, why t dash equal to t? Because we are considering that if time is 8 o'clock here, then similarly time is 8 o'clock in this frame of reference also, and that's why we are considering t dash equal to t, right? So this is a case along positive x direction, right? But if we will consider this position equation from s dash to s or in negative direction, then the equations will be changed like in negative x axis. So x dash, x equal to x plus x dash plus vt, and again y dash equal to y, z dash equal to z, t dash equal to t. This is along negative x direction. Okay, now moving forward, our second subtopic is velocity. So velocity. So from position transformation, we have x dash equal to x minus vt. Okay, moving forward, now we have done till here like x dash equal to x minus vt from position transformation. Now differentiate this equation with respect to t. So what we will get, d upon dt x equal to d upon dt x, this is x dash, minus v d upon dt to t. So we will get dx dash upon dt equal to dx upon dt minus v. And as we know, t dash equal to t implies dt equal to dt dash, right? So we get dx dash upon dt dash equal to dx upon dt minus v. So it gives vx dash equal to vx minus v. So from this we get velocity is variant in Galilean transformations. Now moving towards the final subtopic, that is acceleration. So from velocity transformation, vx dash equal to vx minus v, right? And u implies u equal to u minus v, and u equal to u dash plus v, because it will go this side. Now after time t, new velocity will be u plus del u equal to u dash plus del u dash plus v. So take it equation 1, this is equation 2. So from equation 1 and equation 2, u dash plus v plus del u equal to u dash plus del u dash plus v implies del u equal to del u dash. Okay, and finally divide this equation by del t throughout. Implies del u upon del t equal to del u dash upon del t, implies a equal to a dash. What it means? Means acceleration is invariant, means it does not change under Galilean transformations. So I hope, gentlemen, this topic is clear. Hope you understand this topic. For further understanding such topics, do subscribe to this channel, like the video and share among your friends. If you have any suggestion and want any separate topic to be discussed here, do comment below. In our next video, we will discuss Michelson model experiment. Thank you.